Let's discuss the set of complex numbers. Complex numbers are made up of the set of real numbers and imaginary numbers. Real numbers are made up of both rational numbers and irrational numbers. The set of rational numbers begins with natural numbers. Natural numbers are our counting numbers, such as 1, 2, 3, 4, and so on. The set of whole numbers contains the set of natural numbers, including 0. Oh, it would be 0, 1, 2, 3, and so on. Integers contain the set of whole numbers with the addition of negative numbers. So like a -5, -4, -3, -2. And the set of rational numbers includes the set of integers with the addition of terminating decimals and repeating decimals. A rational number can be defined as a over b, where a is an integer and b is an integer. And of course, b cannot equal 0, such as 1.2. 1.2 is equivalent to 12 over 10. 12 is an integer and 10 is an integer. The repeating decimal of 0.6, which is equivalent to 2 over 3. 2 is an integer and 3 is an integer. A few examples of irrational numbers. Now remember, irrational numbers are numbers that neither repeat or terminate, such as the square root of 17, or the cube root of 5, or the square root of 2, or e, or pi, or phi. These are all examples of irrational numbers. The square root of any negative number is said to be an imaginary number. The square root of a -4, square root of a -17, square root of a -36, square root of a -100, square root of a -113. These are all examples of imaginary numbers. We use the variable I to represent the square root of a -1, which then allows us to express the square root of a -4 as the product of the square root of a -1 and the square root of 4. Substituting an I for the square root of -1 now becomes I to the square root of 4, which is equivalent to I multiplied by 2, or 2I. So the square root of a -4 may be written as 2I. Every complex number is composed of a real part, A, and an imaginary part, BI. So A is our real part, and BI is our imaginary part. A number is said to be wholly imaginary. We'll give it BI if A is equal to 0. And a number is said to be wholly real. In other words, we're talking about the A part if B is equal to 0. Example 1. Identify the real and imaginary parts of the complex number 8 plus 1/3 I. So let's write down the expression 8 plus 1/3 I. That is in the form of A plus BI, A being the real part. So 8 here is our real part. And 1/3 I is our imaginary part. Example 2. Rewrite the complex number 2i using a radical. So let's write the expression 2i. Let's substitute the fact that we know that I is equal to the square root of -1. So we would have 2 square root of -1. We need to take this one step further, put 2 into radical form. So 2 is equivalent to the square root of 4. So let's substitute that in for the 2 here. So we have square root of 4 multiplied by the square root of the -1, which is the square root of -4. So 2i, written in radical form, is equivalent to the square root of a -4.